Learning objectives. In this chapter, the users would learn the following aspects of display cards and monitors. Different types of display cards, resolution and color depth, video memory, video drivers, monitors, CRT construction and working, vertical stage, horizontal stage and 15-pin input type monitor, block diagram and description of color monitor, display configuration, introduction to LCD displays. Display card evolution. Graphics cards were introduced by IBM in the year 1981. These were called monochrome display adapter or MDA. The card provided text-only displays of green or white text on a black screen. The minimum standard for new video cards is Video Graphics Array VGA, which supported 256 colors. Video cards with high-performance standards like Quantum Extended Graphics Array or QXGA can display millions of colors at resolutions of up to 2040 by 1536 pixels. Display card. Display card is an expansion or add-on card that is attached to a computer. It helps a computer to provide graphical information to a display device. The display device could be a monitor, television, or projector. The graphics system of a computer functions powerfully with the help of display card. It enhances the graphics display on a computer and also controls the working of the graphic components with the rest of the computer. A display card is also referred to as graphics card, video adapter, display adapter, or graphics adapter. The image seen on the monitor is made up of tiny dots called pixels. A monitor with a common resolution setting will have more than 1 million pixels. The computer decides what is to be done with every pixel to create an image. A translator converts the binary data from the CPU to the image that we see on the monitor. A translator is not needed if the graphics capability is built onto the motherboard. In this case, the conversion is done by the computer itself. Otherwise, the translation takes place on the graphics card. Display card. Physical properties. A display card is usually rectangular in shape. It has one or more ports on the side that helps in connecting it to the display devices. Once connected, the display card installs an expanded slot for the motherboard. Some display cards have only one port, allowing connection to only one display device. On the other hand, some also have many ports that help connecting to multiple display devices simultaneously. At times, the display card is built directly into the motherboard. Display card working. A CPU works with software applications and sends information about the image to the display card. The display card uses the pixels in the monitor to create an image on the screen. To display a 3D image on a monitor, the display card first creates a wireframe with straight lines. The remaining pixels are then filled in. Along with this process, the display card also adds a texture, color, and lighting. In a game where the images keep changing regularly, the computer repeats these steps at least 60 times a second. With a display card, the workload for the computer is reduced. The tasks of a display card are completed with the help of a connection to the motherboard for data and power. A processor that decides what is to be done with each pixel on the screen. Memory that can hold information about each picture and store completed pictures temporarily. A monitor to see the final result. Most display cards have built-in fans as they generate heat. There are also fanless cards that use heat sinks to pull away heat from the graphic processing unit. Display cards. Components. The main components of a display card are graphics processor, video memory, random access memory, digital to analog converter, also known as RAM/DAC, driver software, VGA feature connector, video in socket, video BIOS, and local peripheral bus. The content in the memory is read by RAM/DAC. This content is converted into analog RGB signal, which is then sent to the monitor through the video cable. This process is repeated several times in a second. A digital lookup table is used by the RAM/DAC to convert the digital signal to a specific voltage level. This voltage level differs for every color. The range of refresh rate the display card can support is based on the speed at which the RAM-DAC converts the information and design of the graphics processor. The RAM-DAC influences the number of colors available for a given resolution based on its internal architecture. Let's now check the components of the display card. The introduction of dedicated graphics processing chips reduced the time taken to process the images. The CPU, instead of sending raw screen image to and from buffer, sent a smaller set of drawing instructions. This is translated by the display card driver and executed by the display card processor. The processor of the display card handles bitmap transfers, painting, window resizing and repositioning, line drawing, polygon drawing, and font scaling. This processor is designed in such a way that it can handle these tasks at greater speeds in hardware than the CPU software. The graphics processor then writes the frame data into the frame buffer. This paves the way for less data transfer and less congestion in the system bus, thus reducing the CPU's workload. I/O ports and interfaces. The input-output ports and interfaces of a display card are D sub-output port, S video output port, DVI output port, RCA output port, D connector, VIVO port, and modular I/O block connectors. D sub-output port. This port connects monitors with analog input. Digital signals go through RAM-DAC conversion before being sent through this port, as it is capable of only analog input. S-video output port. S-video denotes separate video. In the past, video encoders were needed to realize video output. A 5-pin S-video port separates the luminance and color signals in order to avoid interference to enhance signal quality. DVI output port. Many of the graphics processors have integrated transition minimized differential signaling. TMDC transmitter for direct digital output to LCD monitor through the DVI port. This port is needed to ensure digital signal to pass from display card to the LCD screen. RCA output port. It is also known as AV port or composite video connector. It is commonly seen in home electronics devices. It is separated into one video and two audio signals. D connector. The D-shaped connector is used for direct transfer of digital video signals. It is found in HD TV. VIVO port. The VIVO port is a video input-output port. It is found on high-end products and is in the form of a 9-pin S-video port. This can be used along with a VIVO adapter. Modular I/O block connectors. This is in the form of a 9-pin S-video port aided by an adapter with component output to support various HD TV media, including 720p, 720i, and 1080i. This type of adapter will also provide RCA and S-video output expansion. Characteristics of display card. The characteristics that determine the efficiency of a display card are GPU, memory, fill rate, shaders. Graphical Processing Unit. GPU stands for Graphics Processing Unit. It is also called Visual Processing Unit. The frequency of the GPU is measured in megahertz. When the frequency of the GPU is higher, the display card can process data faster. The GPU on the display card processes data in pipelines which are parallel lines. When a card has more pipelines, the data transfer can be faster. Some cards have dual GPUs for additional performance. Memory. Most important characteristics of video memory are size, speed or frequency, and memory bus. A wider memory bus leads to more data transferred per second between the video card GPU and video memory. Modern video cards have memory sizes ranging from 128 MB to 1024 MB. If you have to choose between higher memory size versus wider memory bus, go for the wider bus. Frequency is another parameter that directly affects memory bandwidth. Memory bandwidth depends both on memory frequency and its bus width and is a very important factor in gaming and video rendering. For example, a video card with memory frequency of 1000 MHz with 256-bit bus will have better bandwidth than 1400 MHz memory with a 128-bit bus. For serious gamers, we don't recommend any video cards with less than 128-bit bus. All modern video cards have DDR or GDDR memory. It's usually specified by its effective frequency, which is double from the actual physical frequency. For example, if DDR frequency is specified as 1500 MHz, memory physically operates at 750 MHz. Fill rate. A display card draws images on a monitor by filling the screen with dots. The fill rate is how fast a video card can render and fill the screen image with dots. Fill rates are given in megapixels or gigapixels per second. There are two types of fill rates, namely pixel fill rate, text cell fill rate. Pixel fill rate characterizes the speed of drawing pixels and depends on the operating frequency and an amount of ROP, raster operations pipeline units. Text cell fill rate depends on the operating frequency and an amount of texture units. Shaders. Shaders are software programs that run on the GPU. Shaders are of three types, namely pixel shader, vertex shader, geometry shader. Pixel shader manipulates pixel color to bring out a certain type of effect. Vertex shader deforms 3D elements. It is used to add special effects. Geometry shader generates graphics primitives like points, lines, and triangles. Types of display cards. The four types of display cards are integrated, PCI, AGP, and PCI Express. Integrated. An integrated display card comes with a motherboard. It is also known as onboard graphics card. It is a default option that comes with many motherboards. It is considered least powerful because of the time it takes. Though it can be upgraded, it might require plugging a new display card and ignoring the old one. PCI stands for Peripheral Component Interconnect. This display card, being a part of the older motherboard, uses the PCI slot in the motherboard to connect to the computer. Again, PCA cards are found in older motherboards and are a bit out of date. AGP, it stands for Accelerated Graphics Port. It is a high-speed channel for connecting a display card. AGP display cards have 4 speeds. The speeds are 1x, 2x, 4x, and 8x. However, if the motherboard supports only lesser speed, the display card will behave accordingly with lower speed. One of the significant properties of AGP display cards is that they are highly compatible like PCI display cards. PCI Express. It is the most advanced display card. It is connected to the motherboard's PCIe slot. One of the special features of these cards is that they can be accelerated to a speed of 16x. In addition to this, a motherboard that has more than one PCIe display card slot can have more than one PCIe display card connected to it. Installation of display card. One way to increase the speed and processing power of a computer is to install a display card. A system with existing graphics should be configured before installing new display card to avoid conflict. Uninstall old drivers before starting the new installation. Read the manufacturer's instructions properly before starting the process. The steps involved in installing a display card are: unplug the PC, disconnect the monitor cable from the case's back, locate the old display card and remove it, put the new display card in its place. Once the card is secure, attach all the connectors including power connectors wherever necessary. Close the case and reconnect the monitor and other cables that were disconnected. Switch on the PC. Install the drivers. Restart the PC. Once the installation is complete, it is necessary to check the computer's list of installed hardware to confirm the installation. Extended use of display cards. Initially, display cards were used in desktop computers. These supported playing games and watching videos in good quality. While the primary reason for buying a display card remains the same, the usage of display cards have gone beyond enhancing gaming and media experience. Display cards are becoming a part of computing system. A lot of user interface systems and operating systems, like web browsers, seek a display card to provide improved performance and enhanced visual experience. GPUs have made a prominent presence in most computing devices like laptops, desktops, smartphones, tablets, and computers. Computers are now familiar with specialized processors. Display cards are one of the most successful and widely used items in the computing world. Display cards represent real-time environment with high-end details and great definitions. Advantages of display card. The advantage of display cards is the increase in speed leading to improved system performance. Due to the independent GPU, games and photo or video-intensive applications run faster. Also, a lot of resources from the CPU and memory are freed up since they may have to work harder if onboard video is used. A video card has both a processor and RAM built in, which takes care of the video and frees up resources for other functions. Disadvantage of display card. The disadvantages of display card include the requirement of more power. A high-end card can also require an increase in power supply. It also requires space in the PC case and the appropriate slot. Installation of display card. One way to increase the speed and processing power of a computer is to install a display card. A system with existing graphics should be configured before installing new display card to avoid conflict. Uninstall old drivers before starting the new installation. Read the manufacturer's instructions properly before starting the process. The steps involved in installing a display card are: unplug the PC, disconnect the monitor cable from the case's back, locate the old display card and remove it, put the new display card in its place. Once the card is secure, attach all the connectors including power connectors wherever necessary. Close the case and reconnect the monitor and other cables that were disconnected. Switch on the PC. Install the drivers. Restart the PC. Once the installation is complete, it is necessary to check the computer's list of installed hardware to confirm the installation. Extended use of display cards. Initially, display cards were used in desktop computers. These supported playing games and watching videos in good quality. While the primary reason for buying a display card remains the same, the usage of display cards have gone beyond enhancing gaming and media experience. Display cards are becoming a part of computing system. A lot of user interface systems and operating systems, like web browsers, seek a display card to provide improved performance and enhanced visual experience. GPUs have made a prominent presence in most computing devices like laptops, desktops, smartphones, tablets, and computers. Computers are now familiar with specialized processors. Display cards are one of the most successful and widely used items in the computing world. Display cards represent real-time environment with high-end details and great definitions. Advantages of display card. The advantage of display cards is the increase in speed leading to improved system performance. Due to the independent GPU, games and photo or video-intensive applications run faster. Also, a lot of resources from the CPU and memory are freed up since they may have to work harder if onboard video is used. A video card has both a processor and RAM built in, which takes care of the video and frees up resources for other functions. Disadvantage of display card. The disadvantages of display card include the requirement of more power. A high-end card can also require an increase in power supply. It also requires space in the PC case and the appropriate slot. Monitor. Monitor displays the information generated by the computer. It is a device that is connected to the information source, like a motherboard through a cable. A monitor is also known as a visual display unit. A computer monitor is used to view images, videos, and documents. It transmits information from the CPU. Monitors can be cathode ray tube, liquid crystal display, plasma, light-emitting diode, and organic light-emitting diode displays. Monitors come in various sizes. The latest technology and innovation have improved the quality of display and the functioning of a monitor. An advanced type of monitor with good display provides a better experience to the user. The earliest version of CRT was in the year 1897. It was invented by a German physicist named Ferdinand Braun. It was then called Braun tube. It was made using a cold cathode diode, which was a modification of Crookes tube that used a phosphor-coated screen. Characteristics of monitor. There are various characteristics of monitor that determine its quality. They are size, resolution, bandwidth, refresh rate, interlacing, dot per inch, dot pitch, convergence. Characteristic description. Size. It refers to the diagonal size of the monitor. It is measured from one vertex to the diagonally opposite vertex. Resolution. It is the density of pixel packing. Monitors divide the screen into millions of pixels that are arranged in rows and columns. The display quality of a monitor largely depends on its resolution. On a color monitor, each pixel has 3 dots, namely red, green, and blue. Bandwidth. It refers to the amount of data that can be transmitted in a given period of time. It is expressed in bits or bytes per second for digital devices and in hertz for analog devices. Refresh rate. Monitors have to refresh several times per second. The refresh rate is measured in hertz. When the monitor refreshes faster, it flickers less number of times. Interlacing. It's the technique of scanning an image by alternate lines at each pass instead of scanning one line at a time. This keeps the bandwidth down. With the arrival of latest technology, most of the monitors are non-interlaced these days. Dots per inch. It is calculated to measure the sharpness of the on-screen image. This depends on 2 factors, namely the resolution and the size of the image. Dot pitch. It is a measurement of the vertical distance between each pixel on the display screen. It is measured in millimeters. This is one of the characteristics that determine the quality of the monitor. Convergence. This refers to the sharpness of every single pixel that appears on the screen. Each pixel is made of 3 dots. These dots are of red, blue, and green colors. If these dots are badly converged, the pixel appears blurry on the screen. Types of monitor. With advancement in technology, 3 types of monitors have emerged. These are CRT monitors, LCD monitors, LED monitors. CRT construction and working. The CRT monitor receives video signals from the computer and displays information on the CRT screen as dots. The CRT controller circuit works in synchronization with the CRT monitor. The main unit of the CRT monitor is a picture tube. The CRTs have a conical shape. There is an electron gun at the back of the monitor and a phosphor screen in the front. A beam of electrons fired by the electron gun travels through a vacuum tube towards the screen. The electron beam strikes the phosphor screen and illuminates the spot it strikes. Most CRTs use electromagnetic deflection. This deflects the electron beam to illuminate various spots of the screen. The horizontal deflection coils and the vertical deflection coils deflect the beam in horizontal and vertical directions respectively. The illumination cost remains for few milliseconds because of the persistence of the phosphor. Thus, repeated illuminations cause permanent image on the screen. This is achieved by scanning the screen with electron beam. Raster scan. The most common type of scanning is called raster scan. In this scan, the electron beam is made to move back and forth across the screen from right to left and left to right, from top to bottom and bottom to top. The beam is turned on or off to produce an image. The H-sync from the computer provides horizontal synchronization and V-sync provides vertical synchronization. Interfacing a CRT. CRT can display 2 types of images, namely alphanumeric displays and graphic displays. The alphanumeric displays are used for alphanumeric characters. The graphics displays are used to draw pictures, maps, and charts. They can also display alphanumeric information. Similarly, interfacing a CRT to a computer can be done in 2 ways. These are the TTL video interface, the composite video interface. In TTL video interface, the computer sends a video, H-sync and V-sync signals in separate wires. In a composite video interface, the 3 signals are mixed and sent in a composite video waveform. Based on the interface type, the monitors can be TTL monitors or composite video monitors. Monitor resolution. What is required in a monitor to display the images? One of the most important requirements is resolution. Resolution is the number of pixels that a screen displays for a given size or dimension. The dimension is described as width by height, such as 1024 by 768. This means that the screen is of resolution 1024 pixels wide and 768 pixels tall. It is important to understand that the resolution is independent of the physical size of the monitor. Large monitors can have low resolution and low monitors can have high resolutions. Resolution, CRT and LCD. There is an important difference between CRT and LCD monitors when it comes to resolution. The CRT monitor is capable of multiple resolutions, whereas the LCD monitor has only one native resolution. In other words, high-resolution monitor can show more on the screen. When the resolution is high, the input bandwidth has to be sufficient to allow a refresh of the screen. Refreshing is difficult with high resolution because there is so much information to be sent to the monitor. Refresh rates. The refresh rate refers to the number of times the monitor can pass the beam over the display area. This rate can vary widely depending upon the settings the user has on the computer and what the video card that is driving the display is capable of. So why does refresh rate matter? Viewing a CRT display over long periods of time can cause eye fatigue. Monitors running at low refresh rates will cause this fatigue in a shorter amount of time. Typically, it is best to try and get a display that will display at 75 Hz or better at the desired resolution. 60 Hz is considered the minimum and is a typical default refresh rate for video drivers and monitors in Windows. Color depth. The number of colors that can be displayed on a monitor is called color depth. It is normally described in bits. For example, 8 bits represents 28 colors, which can display 256 colors. 16 bits represent 216 colors, which can display 65,536 colors. Similarly, 24 bits, often referred to as true color, allows for more than 16 million colors. The rule that exists between color depth and display quality is that when there is higher color depth, there is better quality of display. When the color depth is less than 16 bits, the display card is forced to dither the image. Dithering. Dithering is the attempt by a computer program to approximate a color from a mixture of other colors when the required color is not available. Even if the dithering is effective, the image quality will not be good. In such cases, the images will look grainy, pock-marked, or weird. The only advantage of using lower color depth is that it uses lesser memory and compensates for lack of color resolution. But modern systems are well equipped for higher color depths also. It is to be noted, though, that higher resolution and deeper color depth require more video memory. Advantages of CRT monitors. Despite the fact that CRT monitors are becoming outdated, a lot of people still prefer to use CRT monitors for its advantages. The advantages of CRT monitor are, since the technology has matured, they are available at low cost. The color fidelity and the essential graphics necessary for artists are better on CRT. The contrast ratio allows the perception of proper blacks. The dark shades are darker. Images can be adjusted. It is useful for web surfing as it uses color-rich and crisp graphics, and the text is also sharp. It works better at multiple resolutions. Some more advantages of the CRT monitor are the display of a full motion video on CRT is better. CRT monitor gives more pixels. This provides greater screen detail and also the ability to view more of a document without the need to scroll. It has better viewing angles. Modern versions also have a sleep mode for energy efficiency. Flat viewing screens are also available. The strong glass screen does not get easily damaged by casual touch. Disadvantages of CRT monitors. While the CRT monitors have their advantages, there are some disadvantages also. Let's look at the disadvantages. The radiation emission from the CRT monitor is high. The monitor is big in size and so takes up much space. It is heavy, consumes a lot of energy and emits a lot of heat. Measurement differs for usable screen area. There are not many options for mounting on the table. Drawbacks of CRT monitors. The CRT monitors that were developed in the earlier days had a curved screen. However, technological innovation led to the manufacture of flat screens. These flat screens were still bulky in size and heavy because of the cathode ray tube inside. Users who were concerned about the radiation effect used anti-radiation and anti-glare filters. CRT screens also have deep cabinets and rear projection displays for a given size. This does not allow CRT monitors to be bigger than 40 inches. Demand for CRT monitors. The demand for CRT screens has dropped since the year 2000. This drop accelerated in the second half of the decade. The production of the most high-end CRT ended in 2010. In countries like Canada and United States, the sale of CRT monitors ended in 2007. CRT monitors that were less than 5 years old were replaced with the latest technology despite their capacity to perform well. Current need for CRT monitors. CRTs are still popular in industries like printing and broadcasting, professional video, photography, and graphics field. CRT monitors are also being used in the study of brain's visual processing. The speed at which they respond and the simplicity of the design makes them suitable for scientists who need more control over stimuli which are presented to an observer. Health hazard of CRT monitors. Using CRT monitors also results in a lot of health concerns. The amount of radiation emitted by the monitor is considered harmful. The older CRT monitors can contain toxic substances like cadmium. The rear glass tube of the CRT monitor can also be made from leaded glass. Low refresh rates can cause an irritating flick and affect people when viewed with peripheral vision. The high vacuum inside the glass-walled cathode ray tube permits electron beams to fly freely. Although cathode ray tubes have epoxy-bonded face plates and other measures to avoid shattering of envelope, it is important to handle CRTs carefully to avoid injury. CRTs are very hard to be recycled. They have high concentration of lead and phosphorus that are necessary for display. Leaded CRT glass is remelted into other CRTs or broken down and used in construction of roads. Types of monitor. As we all know, monitors are display devices external to the computer case and connect via a cable to a port on the video card or motherboard. Even though the monitor is outside the main computer housing, it is an essential part of the complete system. Monitors are of two major types. These are LCD and CRT. CRT monitors look much like old-fashioned televisions and are very deep in size. LCD monitors are much thinner, use less energy, and provide greater graphic quality. LCD monitors have completely obsoleted CRT monitors due to their higher quality, smaller footprint on the desk, and decreasing price. LCD, liquid crystal display or LCD monitors, display images using liquid crystal display. The main advantage of LCD is that it takes lesser space and is lighter. LCD has replaced CRT by providing better color and picture quality. LCD monitors are energy efficient and can be disposed of more safely than a CRT monitor. Evolution of LCD. Who discovered liquid crystal display? Austrian botanist and chemist Friedrich Reinitzer in the year 1888 first discovered liquid crystals. RCA researcher Richard Williams generated stripe patterns using a liquid crystal material by applying voltage in the year 1962. Between 1964 and 1968, a new team of scientists demonstrated the first liquid crystal display. This innovation paved the way to a global industry that produces millions of LCDs. The most common LCDs that we use these days are based on elements or pixels that are formed by liquid crystal cells. In response to electric voltage, these cells change the direction of the polarization of the light that passes through them. Composition of an LCD monitor. An LCD monitor is made of 5 layers. They are a black light, a sheet of polarized glass, a mask of colored pixels, a grid layer of responsive liquid crystal solution, and another sheet of polarized glass. Working of an LCD monitor. Each pixel on an LCD monitor is made up of 3 subpixels. It has red, green, and blue filters in front of them. Each subpixel is made up of a group of liquid crystal molecules. These molecules are mashed between the 2 polarizing filters and are suspended between the electrodes. The 2 filters are exact opposite of each other. When light comes in from the light source behind the first filter, the filter whites it out. Black is created on the panel when the alternate current leaves the crystals. However, the liquid crystal's polarization is altered by applying current to the liquid crystals. In this process, they twist and change the way the light is passed through. This results in the required color coming from the second polarizing filter, which is displayed to the user. The backlight acts as a cold cathode. There are different numbers of cathodes in the LCD monitor. These cathodes are diffused through a layer of plastic and then through multiple layers of diffusing material. Features of LCD display. There are certain features and attributes that differentiate LCD monitors. They are native resolution, viewing angle, brightness or luminance, contrast ratio, response rate, adjustability. Features of LCD display. Native resolution. LCD monitors are designed to display information in a specific resolution. It is called their native resolution. In digital display, each individual pixel is addressed by a fixed matrix of horizontal and vertical dots. Changing the resolution settings can affect the image quality. Viewing angle. The picture quality is stable when viewed at a particular angle. Beyond this angle, the image can become blurred or even disappear. Viewing angle is not just checked from the sides, but also from top to bottom. Brightness or luminance. It is the amount of light the monitor produces. It is given in nits or candelas per meter squared. 1 nit is equal to CD per meter squared. Typical brightness ranges from 250 to 350 CD per meter squared. Contrast and response ratio. Contrast ratio is a degree of difference with which an LCD monitor is able to produce bright whites and dark blacks. This is usually expressed in ratio. Response ratio is the rate of speed at which the pixels can change color. Faster the response, better the quality of the picture. The pixels and subpixels in LCD panels do not fade off easily. This is because the light from the backlight and the current from the electrodes are constant. Adjustability. LCD monitors can be swiveled, tilted up and down, and rotated from portrait to landscape mode. Because they are lightweight and thin, they can also be mounted in any position. Specifications of LCD display. Some important factors are worth considering when evaluating an LCD display. They are resolution versus range, spatial performance, temporal or timing performance, color depth, or color support. Resolution versus range. Resolution is the number of levels in which the performance feature of the display has been divided. This is often confused with the range of display. Range refers to the limitations of the display, while resolution refers to the function of electronics with which the display works. Spatial performance. The LCD spatial performance is referred to as dot pitch. The spatial resolution of an LCD is expressed in number of columns and rows in pixels. Temporal, timing performance. Temporal performance is a feature which, if smaller, is better. It is the pixel response time of an LCD. In simple words, it is how fast a subpixel's brightness keeps changing. Color performance. Often referred to as color gamut, it is a range of colors that can be displayed. It is a straightforward feature. Having a range of colors that exceeds the content becomes useless. Color depth or color support. It is expressed in bits. It is either the number of bits per subpixel or number of bits per pixel. Often dithering is adopted to double the number of colors that can be displayed, but this is done at the cost of temporal performance. Configuration of LCD display. While viewing images on an LCD monitor, you expect the image to be crisp and clear. In addition, you also expect the colors to be rich and vibrant. The native resolution of LCD monitor should provide the optimal image. The LCD monitor settings allow calibration that enhances the screen's appearance, and it can be done through the control panel. The settings of an LCD monitor are different from a CRT monitor. An LCD monitor at its native resolutions can display text better than a CRT monitor. LCD monitors can support lower resolution than their native resolution. When the resolution is reduced, the image can become smaller and the text will not be sharp. Similarly, the color of an LCD monitor can also be changed. LCD displays use different technologies, namely active matrix technology and passive matrix technology. Active matrix technology. Most LCDs use the active matrix technology. A thin film transistor arranges tiny transistors and capacitors in a matrix form on the glass of display. When the particular pixel needs to be addressed, the proper row is switched on and the charge is sent to the appropriate column. As all the other intersects of the rows and columns are switched off, the capacitor only at the designated pixel receives the charge. The capacitor holds the charge until the next refresh cycle. Passive matrix technology. In LCDs that follow the passive matrix technology, each pixel is charged using a grid of conductive metal. Passive matrix technology based on monitors are less expensive to produce, but it is rarely used because of the technology's low response time and the imprecise control of voltage when compared to active matrix technology. Advantages of LCD monitors. The very fact that LCD monitors began to replace CRT monitors were because of various advantages that LCD monitors had over CRT monitors. LCD monitor is lightweight and is thin. It occupies lesser space. The screen dots do not flicker. The display area is more usable. Adjustment, storage, and movement of the LCD monitor are very easy. It is energy efficient and does not generate much heat. The anti-glare feature of the screen prevents the eye from getting strained. It is good for basic web surfing. There are some more advantages of the LCD monitor. The TFT liquid crystal technology has brought about better image and color quality. It can be mounted as required. It produces low electric, magnetic, and electromagnetic fields when compared to CRT monitors. LCD monitor can be made to large sizes. LCD can play directly from a DVI or HDMI cable and does not require the conversion to analog. A few LCD monitors can also run on the power supply that is received from the computer. This means the monitor will be on when the computer is on. Disadvantages of LCD monitor. While the LCD has certain advantages that solved a lot of issues, it also has a lot of disadvantages. LCD monitors have fixed pixel resolutions determined by the monitor and cannot be changed later. This requires scaling of images, which degrades the images, especially for fine text and graphics. LCDs using analog input require careful adjustment of pixel tracking so that the digital noise in the image can be reduced or eliminated. The viewing angles are very limited. However, at extreme viewing angles, contrast and color reversal is possible. LCD monitors have a difficulty in producing dark grays and black. As a result of this, the contrast is low and the color saturation for low-intensity colors is reduced. Since LCD has an irregular gamma and grayscale, it is not suitable for professional image color balancing. The bright end of the LCD intensity scale gets easily overloaded. This leads to saturation and compression. Since LCD has irregular gamma and grayscale, it is not suitable for professional image color balancing. LCD monitors have many weak pixels, meaning they are permanently on or off. This is because they are not properly connected to the adjoining pixels, rows, or columns. Image degradation can happen in case of moving or rapidly changing images. This is because of the slow response times and scan rate conversion in severe motion artifacts. LCDs have fixed aspect ratio. LCD monitors are more expensive than CRT monitors. LCD monitors have a fragile screen. Casual handling can damage both the screen and backlight lamp. A static image can cause a burn-in effect. There can be loss of brightness and low temperature locations and also much slower response. LCDs have poor display in direct sunlight. At times, their display can barely be viewed. It cannot be used with light guns or light pens. Dangers of LCD monitors. Though LCD monitors do not produce radiation as a CRT monitor does, still the radiation that is emitted from an LCD monitor is enough to cause harm. The manufacturing of LCD monitors requires sulfur hexafluoride. This substance is believed to be responsible for more than 20% of global warming. In addition, the manufacturing of LCD monitors releases a lot of acidic products that cause acid rain. Despite the growing technology, it is good to understand that the products that are being used in the manufacturing of monitors can be dangerous. Disposing the LCD monitor in a very casual way by dumping it into a garbage is surely not the right thing to do. Once it is unusable, the appropriate person or company has to be called to collect the same. There are ways in which parts of an LCD monitors are to be disposed of and recycled. Similarly, it is necessary to understand that it is not very advisable to open or dismantle any kind of monitor without prior training. As the process adopted in the working is complicated, it can result in safety issues. Conclusion. In this chapter, the users have covered the following aspects of display cards and monitors: different types of display cards, resolution and color depth, video memory, video drivers, monitors, CRT construction and working, vertical stage, horizontal stage and 15-pin input type monitor, block diagram and description of color monitor, display configuration, introduction to LCD displays.